In this video, we'll go through scheduling resources and cost problems. And computational problems you'll find behind chapter 8, but before you attempt doing any computational problem, just like with any chapter, please go through theory first, learn it, understanding, and then practice some problems that you'll find behind every chapter. So scheduling resources and cost is the last planning task. Previously, we covered AON diagram where we actually put in a network all activities, and activities had technological or some logical dependencies. Now we are introducing another component, and that's resources. What is resources? Resources can be people, it can be materials, it can be equipment. Every project can be time constrained or resource constrained project. And in this video, we'll be talking about resource constrained projects only. We will not be covering leveling resources, but only resource constrained projects. So in terms of scheduling resources when there is not enough of them, for example, a planner has planned 2 or more activities to run in parallel, considering that he will have enough resources. However, that's not the case. The same resource does 2 or more activities that are actually scheduled in parallel. In that case, we have to firstly schedule resources that takes precedence over technological and logical dependencies. However, we still need to obey these technological and logical dependencies that are given in our AON network that we covered in previous video. Combinations in scheduling resources can be many, so many in fact that even mathematical modeling is not something which is convenient. Even on a small projects, combinations can be overwhelming. So that's why in real life there are often heuristics used. Heuristics, or the rule of thumb in other words, they can be many, but one particular heuristic has been proven to be working very well when scheduling resources in resources constrained project. And that's a parallel method where we schedule in every period of time. So that's period by period, not looking at the whole project. So always one period by another period. So at any period of time, we schedule activity with a minimum slack first, then the smallest duration if the slack is the same, and then if the 2 of the previous conditions are the same, then the lowest activity ID number. Please remember that heuristics do not always give you the best or optimal schedule, but considering many combinations, it does give you good enough schedule. Also, what you need to remember, parallel heuristics that I've just explained is not the only heuristic that is used. Heuristics can have many ways or many rules of being done, and heuristics will be given to you in your task like it is here on the right hand side. Heuristics are used only if it's strictly noted in a question that heuristics are given and to be used. If that's not noted, then you don't use heuristics. Then you go for all combinations to find the best schedule. Why? Because heuristics doesn't give you always optimal and the best schedule. So we'll cover both cases. In the first case, that's the problem number 4 that you'll find in your book. You have prepared the following schedule for a project in which the key resource is a tractor. There are 3 tractors available to the project, and activities A and D require 1 tractor, so A and D here with 1. And activities B, C, F, and E require 2 tractors. Develop a resource constraint schedule in the loading chart. So this is a loading chart. That's how the loading chart looks like, and you always have to develop a loading chart when you have resource constrained project. Use the parallel method and heuristics given. Be sure to update each period as the computer would do. Record the early start, late finish, and slack for the new schedule. So let's cover this problem. We've got 3 resources available in total. We cannot have more than that. In the first period of time, 0, 0 to 1, 2, 3, 4, we've got activities A and B scheduled in our original AON network without loading chart, resource loading chart. 1 and 2, that's 3 tractors in total, so we don't have a problem in this first couple of periods, first 4 periods actually. So let's schedule activity A. Okay, that's the first activity. 1 tractor is here. Duration is 4 weeks. So 1, 1, 1, and 1. And we don't have a problem with activity B for the first 4 periods anyway. So we schedule 2, 2, 2, 2. And obviously we cannot split tasks because that's one of the rules that are given here. So these are the limitations or assumptions that we cannot split activities. And the second assumption is that the level of resources used for an activity cannot be changed. That's not always the case in real life. However, in problems, when you're developing a loading chart, that's always the assumption. So we cannot split it. Once when you start loading it here, you cannot split it. So we have to finish this period 4 to 5 and put 2 here. Okay, what's the next one? Next one is period 4 to 5. The only one 4 to 5 is an activity C. So can we schedule it? C is using 2 tractors and B is using 2 tractors. No, we can't, because that would be altogether 4 tractors and we don't have that. So we have to postpone activity C. That's why we put a little cross here and we move it. We keep moving it if we don't have available places, but here at the period 5 to 6, it's all okay. Okay, so we just put 1x here, which means we moved activity C. Instead of starting at the period 4, we moved it by 1, so slack is not 2 anymore, it is 1. And that is given in this table. So schedule activity E, schedule activity C, but delay activity C to 5, reduce slack to 1. So slack has changed. Okay, let's see which one to schedule next, whether activity D or E, because both are starting at the 5th period. However, activity D has got less slack than activity E, okay, and it's logical anyway because it's using one resource. So we schedule activity D here. We put 1, 1, 1, 1, 5 periods because duration is 5, and all of that makes it 3 tractors. So that is all fine. However, can we schedule activity E then to start period 5? No, we can't, because that would exceed our maximum number of tractors. So we have to push it. And we put crosses all the way through until period 9, where we can first schedule it. However, we moved it by 4 weeks. And now activity E is starting week 9. It's lasting 3 weeks. And that's pushing activity F now to start, instead of in period 10, it has to start in period 12. So the whole project will be finished at the week 14, and previously it was finishing at week 12.